In this video, we're going to learn how to interpret histograms. You may want to check out my previous video on drawing histograms first, since this video will build upon the ideas in that one. I'll put a link to that video in this video's description. In the previous video, we learnt a formula for frequency density. It was frequency divided by class width. Now, sometimes in exam questions, you'll be given a histogram that's already been completed, and we need to interpret it. If we look at this histogram, we know the frequency density of all of the bars already, since we have the frequency density scale. We also know the class width as well, since that's the width of each of the bars. But what we don't know, and it's not immediately obvious, is the frequency. So what we're going to do is take the formula for frequency density and rearrange it so we have frequency instead. To do this, we would multiply both sides by the class width. If we multiplied the left-hand side of that formula by class width, we'd end up with frequency density, multiply by class width. And on the right-hand side, if we multiply by class width, that would cancel the class width on the bottom of that fraction, so we're just left with frequency. We now have a formula for working out the frequency, and we'd probably write it the other way around, so frequency equals frequency density multiplied by class width. This formula here is going to be used throughout this video, so I'm going to place it at the top here. This means I can work out how many people are in each of these bars by multiplying the frequency density by the class width. So if we look at the first bar here, the frequency density is 2. The width of the bar is the class width, that goes from 0 to 10, so that's 10. If I multiply these together, 2 times 10 is 20. So there are 20 people represented in that first bar. Let's try this for the other bars as well. So for the next bar, the frequency density this time goes up to 1.6, and the width of the bar goes from 10 all the way to 25, that's 15. If you multiply 1.6 and 15, you end up with 24. So there's 24 people in the second bar. For the next bar, this one's really tall, so the frequency density goes all the way up to 3.8, and the width of the bar is very narrow this time, it just goes from 25 to 30, that's a width of 5. If you multiply 3.8 and 5, you end up with 19. And for the final bar, the frequency density is low this time, it's 0.5, and for the width of the bar, this one's really wide, it goes from 30 to 60, that's a width of 30. If you multiply 0.5 and 30, you get 15. So you can see if we have a pre-drawn histogram, it's quite easy to work out the frequencies just by multiplying the frequency density and the class width. You may have noticed that all of the bars in a histogram are rectangles, and when we find the frequency here, all we're really doing is multiplying the base of the rectangle by its height, which is the same as finding its area. So the area of each of these bars represents the frequency. You could be asked in an exam question to take a histogram and turn it into a regular frequency table. To do this, we need to write the headings for each of those columns. The first of those columns will tell us what the histogram is about. We can see from the bottom axis this one's about time, and the second column will be frequency. So we just need to write each of the groups, so the first group goes from 0 to 10, and we worked out the frequency for that group, that's the first bar, as 20. The next group goes from 10 to 25, and the frequency we worked out was 24. And continuing this, we have 25 to 30 with a frequency of 19, and for the final bar it was 30 to 60 with a frequency of 15. Sometimes in exam questions you'll be given a histogram, and you may be asked to calculate some particular values. For example, if this histogram shows you the masses of some tomatoes, we could be asked to work out an estimate for the median, the lower quartile, the upper quartile, and even the interquartile range. Let's go through each of these one at a time. Now, in order to answer these questions, we need to know all of the frequencies for each of these bars, so we're going to do that first. To find the frequencies, we're just going to multiply the frequency density by the class width, that uses the formula at the top. So for the first bar, the frequency density here is 2, and the width of that bar, the class width, is 30. So we would do 2 times 30, that's 60. The second bar goes all the way up to 5, and its class width is 10. So we do 5 times 10, which is 50. For the next one, it goes up to 1.5, and the class width is 20, so 1.5 times 20 is 30, and for the final bar, the frequency density is 0.5, and the class width is 40, 0.5 times 40 is 20. Now that we have all of these frequencies, we can begin to answer these questions. So to find the median mass, we first of all need to know how many tomatoes there were altogether. To do that, we just add up all of those frequencies, so 60 plus 50 plus 30 plus 20. And this gives you 160, so there are 160 tomatoes in total. Now we need to find the median mass. The median is the one that's in the middle. Well, if there are 160 tomatoes, we can find the middle by doing 160 divided by 2, which would be 80. If you've already studied the median and the quartiles, you might be confused as to why I didn't add 1 before I divided by 2 here. Now technically I should add 1 before I divide by 2. However, if you're working with a particularly large number of items, for example 160 tomatoes, you are allowed to just half this in an exam. It's going to be much easier to work with the 80th tomato than the 80.5th tomato, especially given the accuracy of this diagram. So now that we know we're looking for the 80th tomato, we're going to count in from the left-hand side of this histogram until we find where the 80th tomato would be. Now if we look at the first bar, we can see there are 60 tomatoes in here, so the 80th one won't be in that bar. But the next bar has another 50. That would take us to 110 tomatoes. So we know the 80th tomato would be somewhere in this bar. The question is where? Would it be towards the start, towards the middle, towards the end? We need to work out exactly where it is inside that bar. Now since we already have 60 from the first bar and we're trying to get to 80, we only need 20 more tomatoes. So we need 20 of the tomatoes out of that 50. As a fraction, that's 20 over 50, which would simplify to give you 2/5. So we're only interested in 2/5 of that bar. There are now 2 different ways that you may go about finding the answer to this question. Firstly, if we only want 2/5 of those tomatoes, we only want 2/5 of the bar, so we can split the bar into fifths like this, and take 2 of them. If we only wanted 2 of them, then we would split the bar here. You can now see that there's 2/5 of the bar on the left of this line and 3/5 of the bar on the right of this line. So there must be 20 on the left of the line and 30 on the right of the line. You can now see that up to this point we have 60 tomatoes from the first big bar, and then 20 up to this line, which takes us to the 80th tomato. So to find the median, we can just read off the mass from the bottom axis here, and I make that 34 grams. So the answer to this question is 34 grams. Now if you remember, I did say there was a second way of approaching this, and some of you may prefer this way instead. This bar has a class width of 10, and we want 2/5 of this bar, so we need to go across 2/5 of 10. So if we work out 2/5 of 10, well you just do 1/5, which is 2, and 2/5 would be double that, which is 4. So if the width of the whole bar is 10, we only want to go across 2/5 of 10, which is 4. So if you go from the left-hand side of this bar and go across 4 units, we end up at 30 plus 4, which is 34. So the answer to the median is 34 grams. Now let's move on and have a look at the lower quartile. For the lower quartile, rather than dividing 160 by 2, we want to go a quarter of the way through the data, so we divide it by 4 instead. If you do 160 divided by 4, we get the 40th tomato. So we're going to look again from the left-hand side and count along until we hit the 40th tomato. Now looking at the bars, the first bar has 60 tomatoes in it, so the 40th one is definitely going to be in this bar. I'm going to show you this one with both approaches again. So firstly, I could say that I want 40 of these 60 tomatoes. 40 over 60 would simplify to give me 2/3. So I want 2/3 of these tomatoes. So if I split that bar into thirds, I want 2 of those. So if I were to take 2 of those bars, I would split it like this. There would now be 2/3 on the left, which is 40, and 1/3 on the right, which is 20. I can then read off where this line meets the axis at the bottom, and you can see that that's at 20 grams exactly, so the lower quartile is 20 grams. If I were to do it the other way, I would say the width of the bar goes from 0 to 30, which is 30, and I want 2/3 of that class width. 2/3 of 30 is 20. So I go from the left-hand side across 20 units, and of course 0 plus 20 is just 20. So we end up with the lower quartile at 20 grams. Now let's move on and have a look at the upper quartile. So for the upper quartile, I would need to multiply that 40th tomato by 3 since I want 3/4 of the data. So 40 times 3 gives me 120. So I want the 120th tomato. So once again, we're going to start at the left-hand side and count along until we find that tomato. So if we look at the bars, the first 2 have 60 and 50. 60 add 50 is 110. So that's close to 120, but not close enough. The next bar has 30 in it. That would take me past 120, so I can be sure the 120th tomato will be in this bar. Now if there are 110 in the first 2 bars, I only need 10 more, so I only need 10 of those 30. So as a fraction, it's 10 over 30, which is 1/3 of that bar. Once again, I'll show you both approaches for this one. So firstly, I could split that bar into thirds like this, and I only want 1 of them this time, so I'd rub out the second line, and this line now splits the bar into 1/3 on the left and 2/3 on the right. So we'd have 10 tomatoes on the left and 20 on the right. We can then read off this value at the axis. Now this time, the value is a bit more difficult to read. It doesn't land exactly on one of the squares, and it doesn't even look like it's right down the centre. So the other method is going to be more accurate. So if we say the width of this bar goes from 40 to 60, so that's 20, and we want 1/3 of that. If we do 1/3 of 20, we end up with 6.6 recurring. So we need to start at the start of this bar, which is at 40, and go across 6.6 recurring. And if we do that, we do 40 plus 6.6 recurring, and we end up at 46.6 recurring. So whilst the first method does make sense, and visually it's quite easy to understand, the second approach is always going to give you the accurate answer, and this would be the one I recommend you adopt. And to complete this question, we need to work out the interquartile range. To do this, we need to do the upper quartile, subtract the lower quartile, and we actually know both of these values since we've worked them out in the previous parts. The lower quartile is 20 grams, and the upper quartile is 46.6 recurring, so we're just going to do 46.6 recurring subtract 20, which is 26.6 recurring. Something else you could be asked to calculate from a histogram is an estimate of the mean. To do this, it's usually easiest to turn the histogram into a frequency table, like we did at the start of this video. So we're going to write out a frequency table for this histogram. This shouldn't take long since we've worked out all of the frequencies. So this one's about the mass of tomatoes in grams, and we need the frequency column. The first bar goes from 0 to 30 with a frequency of 60. The next one is from 30 to 40 with a frequency of 50. And then from 40 to 60, frequency of 30, and from 60 to 100 with a frequency of 20. Now that we've drawn this frequency table, we can calculate an estimate for the mean in the usual way. To do this, we would extend the table and create an extra column for the midpoint multiplied by the frequency. So we need to multiply the midpoint of each of the intervals by its frequency. So for the first interval here, it goes from 0 to 30, the midpoint of that is 15, and we need to multiply that by its frequency, which is 60. 15 times 60 is 900. For the next group, it goes from 30 to 40, the midpoint is 35, and the frequency is 50, so times 50, and this is 1750. The next group goes from 40 to 60, the midpoint of that is just 50, and the frequency is 30, so 50 times 30 is 1500. And for the final group, this one's from 60 to 100, the midpoint of that group is 80, so 80 multiplied by its frequency of 20 gives you this number here, 1600. Once you've worked out this column, you can add all of those together to get the total mass for all of the tomatoes, which is 5750. You then want to divide this by the total frequency, which is this column here. If you add up this column, you end up with 160. Then to find the mean mass of the tomatoes, you do 5750, divide by 160, and I've rounded this one off at 1 decimal place to 35.9 grams. Sometimes when we're given a histogram, we need to write down a proportion or a percentage. Let's have a look at this one here. So imagine this histogram shows us the test scores of some students as a percentage. And then we could be asked a question like this. Students who scored below 60% must retake the test. Estimate the proportion of students that retake the test. So anyone scoring below 60% must retake. So if we go to 60% on the bottom axis and draw a line up, everybody to the left of this line is going to retake, and everyone on the right will be okay. So we're going to use the formula at the top to work out all of the frequencies. Let's look at this first bar here. The frequency density is 0.4, and the width of the bar is 30, so 0.4 times 30 gives you 12. So there's 12 people in that first bar. Now if we move on to the next bar, we don't need the whole bar, we just need this much, because we're going all the way up to the value of 60. The frequency density here is 5, and the width of that bar goes from 30 to 60, so that's 30. 5 times 30 is 150. So if we add these two numbers together, 12 plus 150, we find there are 162 people that unfortunately will need to retake this test. But we've been asked to give this as a proportion. If you're asked to write something as a proportion, you need to write it as a fraction of the whole amount. So now we know there's 162 people retaking, we need to know how many people there are altogether. So let's work out the frequencies of the other bars. So if we start with the remaining part of this bar, the frequency density here is 5, and the width of the class is from 60 to 70, so that's 10. 5 times 10, there's 50 people in that part. The next bar goes all the way up here to 9.8, and the width is also 10 again. 9.8 times 10 is 98. And for the final bar, this one goes up to 4.5, and the width is from 80 to 100, that's 20, so 4.5 times 20 is 90. So if we add up all of those numbers as well, we end up with 238. So there are 162 people that are going to retake and 238 that aren't. This means in total we can add together 162 and 238, and there are 400 students in total. Remember, we're writing this one as a proportion, So the proportion of students that are going to retake is the number that are going to retake, 162, as a fraction of the total students, which is 400. You might be tempted to simplify this, but since they haven't asked us to in the question, I'm not going to. A second question that you could be asked would look like this. Students who achieve 92% or more receive an award. Work out an estimate for the percentage of students that are going to receive an award. So this time I'm going to find 92% on the bottom axis and draw on that dotted line, and everybody to the right of this line is going to receive an award. So let's work out how many people are going to receive an award using the formula at the top. The frequency density here goes all the way up to 4.5, and the width of that class is going from 92 up to 100, so that's a width of 8. 4.5 multiplied by 8 is 36. Now we need to give this as a percentage. In the previous part of the question, we worked out there were 400 students in total. So as a fraction, it would be 36 over 400. This will simplify quite nicely. If you divide them both by 4, you end up with 9 over 100. And 9 over 100 is obviously 9%. So the answer to this question will be 9% of students receive an award. Sometimes in exam questions you'll be given a histogram, but there'll be some bits missing. If you look at this histogram, you can see we don't have a bar from 20 to 25, and also we don't have the frequency density axis at all. We're missing off the numbers there. In a question like this, you could be told, the histogram shows the ages of people at a restaurant, and there are 28 people between the ages of 0 and 20, and there are 19 people between the ages of 20 and 25, and then we'd be asked to complete the histogram. We're going to start by looking at where it says there are 28 people between the ages of 0 and 20. This is helpful because this bar is actually on the histogram. It's this first one here. So we know there must be 28 people in that bar. We know the width of the bar, it goes from 0 to 20, what we don't know is the frequency density, since the scale's been missed off. Now we can work out the frequency density using the formula from the previous video. Its frequency density is frequency divided by class width. So if we do the frequency of this bar, which was 28, we were told that in the question, divide by its width, which goes from 0 to 20, so that's 20, we end up with 1.4. So we know this bar must go up to 1.4, and that gives us a clue to the frequency density scale. So if we put a 1 here, and a 2 here, you can see this bar would now be at 1.4, which is correct. So we can complete the rest of the scale. Every 2 big squares goes up 1 unit, so it'll be 3, 4, and 5. Next we want to add in that bar that's missing between 20 and 25. We're told in the question there are 19 people in that bar. To work out its frequency density, we do the frequency, which is 19, divided by the width of the bar, which is from 20 to 25, so that's 5. 19 divided by 5 is 3.8. So we know this bar needs to go up to 3.8. So we just draw a bar that goes up to 3.8, across, and down like this, and that's now the histogram complete. Now we're going to look at one final question, which also is incomplete. You can see once again it looks like there's a bar missing from 80 to 100, and the frequency density scale is not there. But sometimes you don't need the frequency density scale at all. Let's have a look at this question. So we're told 100 people were timed to complete a maths problem. The incomplete histogram shows the times taken by some of these people. So we know that not all 100 people are currently represented in the diagram. We're told 65 of the people solved the problem in under 70 seconds, nobody took more than 100 seconds, and we need to complete the histogram by drawing the bar for those who took between 80 and 100 seconds. Let's start by looking at this statement here, 65 people solved the problem in under 70 seconds. If we look at where 70 is on that bottom axis, we can see that everyone to the left of 70 would be this bar and this bar here. So these two bars must represent 65 people. Now since when you work out the frequency of a bar, you multiply the frequency density by the class width, you're essentially multiplying the height of the bar by its base, which is just finding its area. So sometimes you can just use the area to help you solve questions instead. So for this question here, the first bar is 4 big squares along the bottom and 5 big squares high. So I'd say there's 20 squares in that bar. The next bar is 3 squares along the bottom and 2 squares high. So there's 6 squares in that bar. Now I know that both of these bars need to represent 65 people. And since there's 26 squares in total, then 26 squares represent 65 people. If I divided 65 by 26, I would find out how much one of those squares represents, which gives us 2.5. So each one of the squares represents 2.5 people. I can now use this information to help me work out how many people are in each of the bars. So if there are 2.5 people in each of the squares, but the first bar has 20 squares, I can do 20 times 2.5, which gives me 50 people. So there are 50 people in the first bar. If I do the same thing for the next one, there are 6 squares here, and each one of them is 2.5, so 6 times 2.5 is 15. So there are 15 people in the next bar. Now we haven't looked at the third bar yet, but if we do, we can count that there are 8 squares. Each one is 2.5 people, so 8 times 2.5 is 20. So there are 20 people in the green bar. At the start of the question, we were told there were 100 people. If we count up the people we've got already, we've got 50, plus 15, plus 20, which makes 85. So if we take this away from 100, we find there are 15 people not in the histogram. So they must be represented in the final bar from 80 to 100. So in this final bar, there's going to be 15 people. And we know that each one square represents 2.5 people. So if we do 15 divided by 2.5, we end up with 6. This tells us there must be 6 squares in this final bar. Since the final bar needs to be 2 squares wide and represents 6 squares in total, it needs to be 3 squares high, so we draw a bar like this, and that's the completed histogram. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and now go and check out the exam questions in this video's description.